Hey, it's me, Wyatt, and I'm here to talk about my POE final project. This project will be following the design process, which starts with define the problem. Define the problem. Because of the recent outbreak, some people might not be able to buy food. This projectile launching device will allow people to hunt for game with ease. Constraints on this project will be the weight, because the project cannot weigh too much, the building materials, because everybody only has access to what they have at their house, and the maneuverability. The device should be easy to handle. The next step in the design process is to generate concepts. The first brainstorming idea I come up with is to make a normal crossbow out of wood. Your everyday crossbow that has a bolt on the top that you'd hold and shoulder. The trigger mechanism for this thing would be a normal sized trigger with a piece of wood coming off that would release the bowstring and then pull the bolt forward, launching it. These designs will be made from a 2x6 cut to 4 foot long, the dimensions being 1.5 by 5.5 by 4 foot. The second design will be a shoulder mounted launcher that has a trigger mechanism that is squeezed to release the bowstring. The next part of the design process is to develop the solution. My solution will go with design number 2, the shoulder mount. You can see on this sketch that I add a dip for the shooter's shoulder and 2 boxes that you'll be able to put your hands through and hold. The box closer to your shoulder will have the release mechanism that once pulled down will release the bowstrings. I'm thinking of doing a circular bow to put the strings on, but that might change later because I think I want it to be a little bit more curvable. The constructing and testing phase of this project will begin with me cutting out the shoulder for the bow, and as you'll see in this time lapse and this right here, it's a nice little curve. The next part I build is the handle that the trigger mechanism will go in. To do this, I drilled 2 holes and connected them with a saw and cut them all out and shaved it off. You can see a little bit of my process going here. I'm just kind of working on it. The changes I made to my design was to not put the other hole where your hand goes because your hand can hold it without being in a hole. The bows that I talked about earlier, I used plywood just like this. I cut it into 2 strips. The reason I use plywood is because it's really malleable. It can bend very, very far. You'll see in some of the next pictures that I'm showing that I've used it. I used 2 sheets of it, 2 1/4 inch sheets to make 2 1/2 inch, and the reason is friction will keep it together. The next thing I did is I used a chipping device, a chisel, to chisel out a knock or a little divot for my bolt. In this part of the video, I made my trigger mechanism out of wood, a spring, and a dowel, and the dowel pops up because of the spring and holds the bowstring back. In this video, I'm testing my bow for the first time. I'm pulling it back and I'm putting that bolt in. Right now, what's going through my head in this video is I'm going to send that bolt flying. I'm going to send it probably like 300 miles per hour into that barrel. As you can see, I'm taking my time because I want this moment to be a sweet and long lasting. I'm getting ready to fire this huge bow. I'm going to might even go through all the way through that metal barrel, who knows. And it goes about 2 feet. Using the data I collected, I synthesized that my bow needed a little bit more power, so I tied the string tighter, and I got to work. I loaded it up, and because I tied the string tighter, it'll have more power going forward, and it'll launch that bolt a little bit farther. But this is a process of collecting how far it went and shooting. So I tightened it 1/4 inch, the string, and let's see how far it shoots. About 5 foot, 7 foot, anywhere in that order, I'd say. The process of firing and tightening the string until I had it where I wanted. I wanted to test how accurate it was at a distance. Shot one at 5 yards, hit vertically correct, a little bit high on horizontal. Shot 2, 10 yards. Shot 2 at 10 yards, a little bit low, still perfectly on center, perfectly vertically on center, a little bit low horizontally, which you'll probably be able to tell if you drew an arc where you think I'd shoot. I probably shot 5 foot high, 10 foot low. So we're gonna try 15 foot next. For this shot, I'll be angling my crossbow up a little bit to, get a little bit farther, but the box fell over, so we're gonna have to go put that back up. Back up, and we're ready to shoot. Ooh. All right. Go. Shot 3, as you can see here, skipped off the ground and hit the bottom of the box. I'm gonna count it as a hit. Even though it did ricochet off the ground, it still did hit the box, and you can see it's off a little bit to the right vertically, and it's way down horizontally. But that's because it's at a very, very large range for a homemade bow. Next thing I tested was accuracy at range. Accuracy test, shot 1. Yeah, that's a hit. Test number 2 at 5 yards. Shot 3, 5 yards, accuracy test. That is a test 4 at 5 yards. Last one. That is another hit. For this test at 10 yards, the shot missed. The audio was bugged out when we transferred it, so it wasn't there. Alright, test shot number 2 at 10 yards for accuracy. That is a hit. Shot 3 at 10 yards for accuracy. Test shot number 4 for accuracy at 10 yards. That's a hit. A 1 at 15 yards for accuracy. Ooh. Alright, test for accuracy. Number 2 at 15 yards. Ooh, barely a miss. Shot 3 at 15 yards for accuracy. Ooh, another miss. Test 4 for accuracy at 15 yards. That's a hit. Using all the data we collected in the last shots, we can put together a chart of accuracy versus distance. Distance is measured in yards using a rangefinder, and accuracy is measured by if the projectile strikes the target. As you can see, at 5 yards, we had 100% accuracy at every time. 10 yards, we only missed 1 out of 4, 75%. And at 15 yards, we had 25% accuracy. 1 in every 4 shots hit the target. As I reflect over my project, I will show some pictures of the sketches. I believe that the objectives I set myself for this project were accomplished very well. The evidence to prove this is that during the testing phase, my bolt accurately hit a target from distances varying from 5 to 15 yards. The projectile would be successful in the scenario given to hunt game during an outbreak for food shortage. One thing I would change my mind in the design is the trigger mechanism, because the current mechanism did not function as efficiently as I thought it would in the real setting. The results for the testing of the prototype were better than I thought they would be. With some tweaking of the tension of the string, the projectile hunting device was able to hit targets accurately up to 15 yards away. These results from the testing phase show that the projectile hunting device fulfills the tasks in aiding the user and to collect game. Be successful in the scenario given to hunt game during an outbreak for food shortage. One thing I would change my mind in the design is the trigger mechanism, because the current mechanism did not function as efficiently as I thought it would in the real setting. The results for the testing of the prototype were better than I thought they would be. With some tweaking of the tension of the string, the projectile hunting device was able to hit targets accurately up to 15 During the project, I learned that wood is a lot more malleable than I originally presumed, and I also learned that a lot of tension is needed to create the force necessary to launch a standard-sized bolt. The challenges I faced were being able to collect supplies for my project because of the pandemic, and also